All right, good evening once again. I want to talk about the band theory for semiconductors. So, you know that semiconductors have been grouped into two. We have the intrinsic semiconductors and the extrinsic semiconductors. Okay, now for the intrinsic semiconductors, they are pure semiconductors. The number of electrons is equal to the number of protons. Now, at 0 Kelvin, this is how it looks like. There is a valence band which is completely filled with electrons, and there is a conduction band which is totally empty, but it has a very narrow forbidden gap. Okay. However, when temperature increases, or at room temperature, okay, what happens is that, let's say at around 30 degrees Celsius, the heat is enough to thermally excite some of the free electrons. Okay, so you can have some of the free electrons, that is at room temperature or at 30 degrees Celsius. You can have some of free electrons exciting or moving from the valence band to the conduction band so that they can be able to conduct. However, if you apply heat, or if heat is applied to the whole system, then more electrons will be able to move from the valence band into the conduction band. So that is what happens with the intrinsic semiconductor. If I come to the extrinsic, we have two types. We have the N type. Okay, the N type meaning that there is more negative than positive. Now what happens with the N type is that the N being the majority charge carriers, please, it creates what we call a donor level. Remember, I've already explained that for N type, there is more holes and they are there to donate. Okay, so it creates a donor energy level. So the energy level that it creates is very close or beneath the conduction band. Okay, so what happens is that it has its own electrons, and the electrons here will be able to excite to the conduction band so that they can conduct freely. Okay, so the donor level here is very close to the conduction band, that is at absolutely normal temperature. Okay, however, when you apply heat, you have more electrons moving from the valence band coming to the donor level and then also moving to the conduction band. But because of the donor level, okay, there are electrons here that can be able to move easily to the conduction band to enable them conduct. Okay, that is what happens. So we have the donor level which is being created just beneath the conduction band. Okay, but for the extrinsic p-type semiconductor, it creates what we call an acceptor level. Here the acceptor level is rather closer to the valence band. Okay, the acceptor level is closer to the valence band, and therefore here it reduces the space between the conduction band and the valence band, therefore reducing the forbidden gap. Okay, so you have acceptor electrons here to be able to accept, and then they will move from here to here for electrons or for conduction to take place. However, when there is increase in temperature here too, you have more of electrons being accepted. Okay, now the difference between this and this is that in both anyway, there is reduction in the space of the forbidden band, but the N type is much faster or conducts more than the P type. The reason is that, you see, the P type, the acceptor level is closer to the valence band. Okay, and therefore it requires more energy for electrons to move from the valence band here or from the acceptor level to the conduction band. However, with the P type, the donor level is much closer to the conduction band, and since it is closer to the conduction band, it is very easy and requires less amount of energy for electrons to move to the conduction band for conduction to take place. So that is the difference between the extrinsic N-type semiconductor and the extrinsic P-type semiconductor. Okay, the next thing that I would like to tell you is that, please, both the N-type and the P-type semiconductors, they are neutral. Even though they have impurities introduced in them, they are all neutral. Okay, so the impurities are there to just show us that the P is majority or P is minority. But aside that, they are all neutral. Okay. The next thing that I'm going to talk about is the P-N junction. The P-N junction. Thank you.